Alright, Algebra 1, here we go. Let's get started with Chapter 6, first section, solving systems by graphing. And our essential question is, how can a graph help you find the solution of a system of equations? Okay, I guess we should start out talking about what is a system of equations. Okay, system of equations is two or more linear equations that form a system of equations. So something like this. There's two linear equations, x is to the first power in both of them. So as long as you have at least two of them, two unknowns, x and y, two equations, we call that a system of equations. Okay? What is a solution for these systems of equations? It's any ordered pair that makes all the equations in the system true. That means you can take that answer for x and y and plug it into the x and y in both equations, and you get true statements in all of them. So like this for example here, is 2, 4 a solution? Plug the 2 in for x, the 4 in for y into each equation. You can see I did 2 for the x, 4 for the y. 4 equals 4, that checks. 3 times 2 is 6, minus 2 is 4, 4 equals 4. So it checks. 2, 4 solves both of them. So it is a solution to the system of equations. Okay? So that's a linear equation, or a system of equations, and that's what the solution looks like, what it does when you plug it back in. Okay? How does the graph help? Well, right here. Okay? It's one of the three ways we're going to look at to find that solution, that 2, 4 in this example that we just used. So how to find the solution using the graphing method? We've been graphing lines in here. All you're going to do is graph each linear equation, and then their point of intersection is the solution, if it intersects. Okay? So when we look at this here, graph and find the solution. Okay, it looks like this. Given these two equations, y equals x plus 2 and y equals 3x minus 2, it's the one we just did. And I want to point out here, when you're using the graphing method, it's a better idea to graph them when both of the equations are in the y equals. If they're not, you can put them into it. That's just an extra step you got to do. But all you're going to do is graph them. There's your y-intercept. Your slope is 1. So my intercept is 2, up 1 over 1 for my slope. The blue line is the first equation. The second line, y equals 3x minus 2. My y-intercept is negative 2. My slope is 3. That's up 3 over 1. Draw it there. Now graph paper is pretty essential here, because if you do it by hand, it can get all kind of cockeyed. But use graph paper on this, and I've got some here. So you can see where they intersect at, 2, 4. Okay, the exact same solution we just had when we plugged it in to check it. So that intersection is the solution. Remember, each line represents all the points that I can plug in x, y into that particular equation and solve it. So what we're looking for is the point, or the answer where they both intersect. That's the point that solves both of them at the same time. Okay? So, will it always be an intersection? No. There's three types of solutions. One is you graph the two lines and they intersect. One solution, like that example. You can get infinitely many solutions. Sometimes when you look at your two equations and you graph them, they graph on top of each other. They're the same line. So that's infinite many solutions, because you can take an infinite number of points off the line and plug them in, and it'll work for both of them. Okay? A lot of times too, you'll see that the equations are the same equation even before you graph them. Sometimes there are multiple, but it's the same equation. And then sometimes you're going to graph both your lines and they're going to be parallel. There is no intersection, so there is no solution. Okay? If the lines don't intersect, then there's no point that solves both of them simultaneously. Okay? So this is the first of the three methods we're going to look at here. We'll spend a day or two here going over this, because we've been graphing lines. It's just graphing two lines on the same graph now, and then looking to see what the solution looks like. It's going to be one of these three situations right here. Okay? So we'll be graphing tomorrow in class. We'll look at a little application of this, and then we'll move on to the second thing, which is substitution and then eventual elimination. Okay? So we'll get on this tomorrow. All right, we'll see you then.